Fuel cells. Introduction. Fuel cells release chemical energy and transfer energy electrically into other useful energy stores. Fuel cells do not use combustion to release chemical energy. They use electrochemical reactions instead. Fuel cells can be used for lots of different purposes. Fuel cells can be used in cars so that other fuels, such as hydrogen or ethanol, can be used instead of burning fossil fuels. Fuel cells have even been used for space exploration. Apollo 11 is the name of the first space mission to land humans on the Moon. The lunar landing module used hydrogen fuel cells to provide electricity for onboard equipment and to produce drinking water for the crew. This is a fuel cell. Just like chemical cells, a fuel cell does not use combustion of the fuel to transfer energy. Did you know? Although fuels are generally substances that react with oxygen in a combustion reaction, this is not always the case. In a fuel cell, for example, energy is transferred due to electrochemical reactions, not combustion. So let's have a look at how a fuel cell works. Fuel and oxygen are continually added into the fuel cell. Fuel and oxygen are the reactants. A chemical reaction occurs within the fuel cell. The chemical reaction that occurs is the oxidation of the fuel. Oxidation of the fuel creates waste products which leave the fuel cell. When a device, for example a light bulb, is connected to the fuel cell that is generating a potential difference, it turns on. If the supply of one or both of the reactants stops, the fuel cannot be oxidized inside the cell and the fuel cell stops generating a potential difference. As a result, the light bulb turns off. Now let's look at a specific example of a fuel cell, the hydrogen fuel cell. A hydrogen fuel cell is a type of fuel cell. Hydrogen is the fuel. Hydrogen reacts with oxygen in the fuel cell and gains oxygen. The chemical reaction that occurs is the oxidation of hydrogen. Water is the only product in the reaction, which is a waste product, and it is removed from the hydrogen fuel cell. Let's look inside the fuel cell to see the chemical reaction more closely. Hydrogen and oxygen molecules enter the fuel cell. Two hydrogen molecules react with one oxygen molecule. They produce two water molecules. The overall equation for the oxidation of hydrogen in the fuel cell is 2H2 plus O2 reacts to form 2H2O. The two water molecules are then removed from the fuel cell. Okay, so let's recap. Hydrogen and oxygen undergo a reaction in the fuel cell. Hydrogen is oxidized and water is produced. Water is removed from the fuel cell as it is a waste product. In summary, fuel cells generate a potential difference by oxidizing the fuel. In a hydrogen fuel cell, hydrogen is oxidized to produce water only. The balanced symbol equation for the overall reaction in a fuel cell is 2H2 plus O2 reacts to form 2H2O. A potential difference will be generated provided both fuel and oxygen are continually provided to the fuel cell. Keywords: electrochemical reaction, a chemical reaction that generates or requires a potential difference. Oxidation, when a substance gains oxygen. Potential difference, a measure of how much energy each charge in a circuit is carrying.